Alright, so welcome back to another video on Node.js and what are sockets. So after I saw in this Node.js course of several modules, so from the fundamentals in the architecture, how Node.js is designed, also look at the module system, the CommonJS and the Node package manager, and to get some real life experience and projects such as working with the working with string API and the file input and output, right? To see how that works behind the scenes, how you can do that synchronously and asynchronously, right? And also uh, take a look at a more complex project and how you can set up a web server from the scratch and to make it much more modular by following is the MVC pattern, for example, and understand the RESTful architecture, which is an architectural design that allows to communicate uh, different applications. So by looking here at RESTful, mhm, Jesus, this is a huge document. That's what happened. REST, RESTful, right? Sending the cameras and RESTful and REST. Okay, so RESTful API. So again, REST is this architectural design for designing API, this application programmable interface that a Node.js server expose all of this capability that a server can have, right? So after that, the RESTful API uh, and also the way of how you can test your endpoints and all the different tests that you can do. For example, unit tests, which are focused on components, and they are basically are isolated. Whereas in the integration, you test is how two different model functions, components, uh, or applications communicate each other, and then you have the integrate the E2E test, right? Which is testing a whole user experience, right? And they usually perform on the browser. So on that, I also look at when you're creating your Node.js instance, especially for scalability, uh, we rely on the package called cluster that allow us to match the number of logical cores to Node.js instance. Or that's the common pattern to do that. You can create as much Node.js instance as you want, but the approach is to match the number of logical cores to the Node.js instance you can create. Uh, and see how you can do that, for example, using tools like PM2, which is project management tool. Uh, project management 2, I don't know what happened with project management 1. It's a mystery. And you can also see these two different approach of scaling your application to handle load. right? Again, load balancing is a particular field by itself, but the whole idea here is that using the cluster model and approach something called the round robin, which is going to depend on how the OS handle that. But this works by handling incoming requests uh, per process, and one incoming request will be handled by one particular process, and the second request will be handled by a second process, and so on and so forth, right? And the round robin is much like the baseball, right? Well, all the players, the hitters, uh, play one by one, and then it go again. So the complete round is complete. In other words, so let's, for example, you have three. Yeah, for example, if you have three Node.js instances and you receive incoming requests, so the first request will be handled by the first Node.js instance, the second by the second Node.js instance, the third by the third Node.js instance, the fourth by the first Node.js instance, and so on, right? And the cool part of this is that using cluster allows you to do this, and because this is the the, the mechanism, the default mechanism that was set up when we set when Node.js was born. So this is a rock solid approach, unlike the worker approach, which the sole difference between the cluster and worker is that with clusters you can create one instance per thread, whereas in workers you can create multiple instances per threads. And this is trying to bring this JavaScript to be a multiprocessing language. And again, the rule of thumb is, so right now stick to the cluster approach, which has been proved to be a very well approach when it comes to scaling your application. Okay, to handle more incoming requests. I also look that because with clusters, the state of the application remain on each one of those node instances per threads. They cannot share state across the instance. So that's the reason why we use another server or a database to persist the state of our application outside of the server. So I also look at from the overview database landscape from IBM blog post, where they show you is first the license that you need to use, especially if you're gonna choose a database and pick what will be the best fit for you. Understand the license, the more restricted and the open source license, which is a spectrum after all, and also look at the examples of database map to license. When you have, for example, Redis, you use an AGP version 3, whereas the RabbitMQ is public domain. You also have Apache that uses the Apache license. You also have all, for example, IBM, which is a proprietary license for the store of data. And the five most common type of family you can use or that are in the industry, such as document base, key value, um, relational graph, and white column, right? So I also saw how can I use, for example, Mongo to as our data store and Mongoose to make our life much more easy when it comes to mapping documents in a document-based database. I also saw how can I create documents and how to create, update, and do the code operations, create, read, update, and delete in a Mongo database. And then how and then how can I version my API by using this a particular approach when this is versioning your API is important, especially when you want to serve to multiple clients. Let's say for the laptops, mobile, perhaps the IoT. So versioning your APIs not only bring you security to your application, but also you can tell users to update to the newest version of the API when they see fit, right? So you can develop new features while maintaining is the backward compatibility and let the users uh, do so update to their newest version. I also see how can I versioning a Node API using Express, okay, and yeah, this is more like for adding paginations to this, some more advanced feature for that. Okay, so persistent state that. And then I look at the Node.js security and authentication. So uh, this might be another a topic by itself, all right? But when it comes to security and authentication, it's important to understand is the encryption. Okay, encryption is for encrypt your connections as one layer of security, the SSL and TLS. Okay, and how you can set up a HTTPS in your server by using its digital certificates that provide you to prevent you man in the middle attacks. Okay, so I also saw how you can set that on development or uh, in production as well. I also see an example of how can I do that. All right. And another layer of security is secure your headers, so only expose relevant information or only necessary information in your headers. So following is that particular approach from security, uh, expose only what is needed or send only what is needed. And then I look at the authentication and authorization. Okay, and authentication and authorization uh, understand the difference between these two words. You have authorization and authentication. So authentications validate if the user are who they claim to be, whereas authorization is allow an authenticated user to access a certain area in your application. Then I look at the different type of authorization and authentications So for example, like social sign up, and the importance of using this, especially because it really does, for the user perspective, the necessity of storing individual password for all of their website directories, right? So Facebook, Twitter, Amazon, Apple, uh, Google made this particular authentication, which is the OAuth method, something I'm going to describe later. Uh, but we have for the authentication authorization API key. So the purpose of the API key is to identify an application. Okay, so it's for prior identification and prior authorization. So with API key, the trade-off is that we don't have too much information about who is accessing to our application, and that lead us is to the GW token. Okay, so with GW token, which now is a token-based authentication, provides you is mm, the ability to identify a specific user on your application. So they act as a set of credentials, this GW token. I also look at how this communication works, how this GWT token based authentication works, and also is the OAuth, which again, this approach is being used by all of these top tech companies, and the main issue is to solve the necessity the users needs to remember all their key or the password from every site they have to sign, right? So what you're doing is you delegate as a user all of this responsibility to these third-party vendors, okay? And that is something that might not work as well as intended, right? So you're giving away a lot of by convenience, you're giving away a lot of your data and your responsibility, hoping that they are behave or they are representing your interest. It's like, uh, yeah, good luck. It's like, yeah, good luck. There are, of course, there are other alternatives that you can use to manage your password in a much more easy, secure way. It requires you to know at least a little bit of, to have at least the attitude to learn more about that. It's not that difficult. It just requires you time, but what you will get is very, very, very important because it's control about your data. But in any case, this is not a privacy control class, right? This is an overview of now the OAuth flow, or the OAuth 2.0 authentication code flow. And the funny thing is that when I saw that, because I memorized all of this different steps that are in that OAuth method, what you have is the user, the server or your application. So you have the users, you have the client, you have this your server application, and the authorization server. And all the magic happening is on the authorization server. I also look at this particular graph where a would explain you what's happening in the OAuth code flow. Okay, so anytime so a user login into your website using the social sign-in, it sends an authorization code request to your server. I mean, it sent you an authorization code request to the authorization server. The server responds with a authentication prompt, so the user now can log in their favorite uh, top tech company account, okay, whether it's Google, Apple, Facebook, you name it. Uh, it sends those uh, credentials and consents to the authorization server. The authorization server now sends an authorization code response to your client. The client now sends this authorization plus this code it received to the authorization server as a token. So the server now get you the access token. Okay, and this is an optional, all right, the refresh token, but it gives you the access token to the web app client. And now with this web token, you can request start. You can make requests to your server. So this is the entire goal of the OAuth authentication code flow, right? I also saw how can I do that, all right? Not only in theory but also in practice on how can I set up that from Google, all right? And also a code that allows to make this authentication. And to make our life much more simple and easy, I saw the Passport.js, which what it does is to expose common approach of doing authentication regardless which provider you want to use or which standard. So it provides you a plugin where it allows you to set a particular approach you want to use. Let's say you want to implement a Twitter, as I said, you want to implement Twitter, Google, or Apple, so you can do that easily using Passport. And well, how in a place where you should store your client secrets, right? Using, for example, .env to do that. And now taking a closer look at how you can set up that, all right, in a much more friendly and easy way to do this. Also look at the cookie-based authentication, and it's going to depend of how do you want to implement that, the authentication or the season, because security is your main priority. You want to implement a server cookie season, whereas is security is not a concern, or it's not that much a concern. Well, you can implement this a cookie browser authentication. So after that, okay, after this, then I look at the continuous integration and how by following is this development practice uh, to help you and your team to collaborate in distributed teams on a much larger project. So this CI and CD are development process and practice to get some quality data and easy way to integrate that. So CI and CD, in short, in the case of CI, is just a server where you define is a set of tests uh, and then you construct your application to check if anytime you or your other team members or your teammates make a push request, okay, to the particular repo, and those change has been approved by other developers, well, you can make sure that all of these code integrations won't break your application. The TLDR is that. So how you can do that? Well, by defining is a particular pipeline for that. The other is the continuous delivery, which is now taking a further step in how do you automate this process by now setting a particular user accepting test or user accepting criteria. For example, you might have a quality assurance team that set all of this tests, right? And then you have continuous deployment, where the end goal is to anytime a developer push code to a master branch, it passes directly it build and deploy your code to production. And again, there's some scenario where this might work, this might be helpful. For example, creating chat applications. Okay, uh, you might want to do that, but in other industry, for example, like the healthcare, you don't want to introduce a bug in there. In fact, you want a very well battle test application. So it's important to understand that, right? So what is continuous integration? What is continuous delivery? And what is continuous deployment, right? I also look at how can I do that, all right? By using pipelines with this. Mhm. By using pipeline with this, when you define a workflow or a pipeline. For example, the build and the test step before deploying that to production. If you have a staging side. I also look how you can do that with GitHub Actions. And the beauty of this is that they provide you a CI server that trigger a GitHub workflow, okay, as part of some of the tasks you define on that workflow. And the workflow here is just a YAML file where you define is the build step and the test step. And it was actually pretty fun. Yeah, I really loved it. I also saw how can I do that, okay? And how you can reuse some of the other most a widely uh, code. So for example, like git push. So using GitHub or using the actions of checkout. So instead of writing your own job, so you reuse this particular job. What it does is to push the code into the CI server for you. So that's actually pretty cool, pretty amazing. Build pipeline in action, right? Build pipeline in action, and I saw how can I set that up on GitHub Actions, all right? And take a look at the GitHub Action Marketplace. Again, providing you and all of these mostly common um, code or workflow, GitHub Actions workflow for very common tasks. So for example, check out to a CI server or deploy to an AWS instance, EC2 for example, and so on and so forth. Uh, and mocking our database, which is a very interesting approach, by the way, a very interesting approach, especially when you want it to mock real life database or real life, yeah, when you want to mock real life data. So for example, you pull up the migration from your from the production database, and then you uh, push that into your staging environment. Okay, so now what you can do is to test from the real life application or from the real life world data in your mocking scenario using the CI as part of that. I also saw how can I do that using a MongoDB in GitHub Actions, which is pretty cool, totally. And no production and the cloud. Okay, here uh, the whole idea of this course is to understand now once you build your application, you scale that, you persist the state of your app outside of that in a database, then you versioning your API to serve to different clients and secure your application by setting the HTTPS and providing another security layers such as secure your headers, authentication and authorization. Perhaps you are using as a GWT token or a cookie-based season, perhaps a OAuth 2. Uh, Now, if you want to, once you do that, you can set up a CI/CD, you can set up a CI/CD pipeline to make your applications much more collaborative, battle test, and make any feature you add be released as soon as possible. You have this entire pipeline of co-integration and continuous delivery by setting as a quality assurance team or a set of quality tests for that. And ultimately, depending on which type of application you're building, a a continuous deployment, right? So anytime a developer push the code to the master branch, now that passed through the entire pipeline of the test, check if all of those tests, or check if that code passed all of these tests, and then, only then, it deploys to production. Great. So far, we have now our application, but it's running locally. So how can we expose that to the internet so anyone can access? This is where it comes, no productions and the cloud. Because here, okay, is when we can select different cloud provider vendors, such as from Google Cloud, Microsoft Azure, or AWS. Okay, understand the concept of serverless versus containers, whereas serverless is this new approach that, even though that the name might be a little bit deceiving, but we still have server. The only It's just that the cloud manage the configuration of all of these servers, so you don't have to worry about setting up an OS, scale that up. Only we need is only The only thing that we need to know is that our code will run. So when our code will run and what it does. That's the only thing that we need to focus. It's on the logic. Okay. Again, this is a form of event-driven programming this serverless? In, it might depend or not on your situation, okay? Because for example, Lambda functions or these serverless functions runs your serverless code, but if that go to sleep, you need to restart the server before it can respond to any request. It also can be expensive to set up a server like that, or to maintain a server like this. So this is the first approach, the serverless. And again, we are talking about it when it comes to deploy your applications. There are two main ways, right? You have the serverless and the containers. So yes, so serverless is a form of this event-driven programming where now all of the server configurations are handled by the cloud. You just only need to know when this code will run and what it does. Okay. It also comes with some trade-off because yeah, it also comes with a trade-off. Okay. It also might come with a trade-off. Exactly. It also may come with a trade-off here. It also comes with a trade-off because uh, if you're not careful how you set up your serverless architecture, you might suffer from high latency first. Okay. If you're not careful how you set up your architecture, you might suffer from high latency. And this might happen if you land a server or if you land a function which runs this serverless, which runs your serverless code, go to sleep. You need to restart before it can respond to any request. This is one of the trade-off of this. Okay, so you need to be careful about how you set up your serverless architecture, because this lambda function which runs your serverless code, if they go to sleep, you need to restart before it can respond to any request. Okay, and also you can be locked to a single cloud provider, which there will be a costly migration ahead of you, right? If you find yourself, you might find yourself with the ability to deploy your apps on premise, on servers, which means on physical servers. And then you have the another approach, right, which is virtual machine of the container. But to understand container, we need to know what is virtual machine and what they offer. Is that self OS? It's an entire OS running on top of your machine. Okay. The trade-off, in contrast with a container, where containers are only run sandbox applications on top of your OS, not of your machine. Okay, and the trade-off is that virtual machine provide much more are much more robust when it comes to security, whereas containers, the the advantage is that you have much more smaller application, much more lightweight application. So again, this is part of the trade-off, especially when you want to run multiple applications. In the context of virtual machine, especially when security is a concern, is used by Amazon EC2 because I don't want to make any risk on that. You know, it's like they don't want to make any risk on that. But not at all, my friends. Not at all. Not at all. And that's exactly what we did here, right? So EC2, we create an EC2 instance here. What we're talking about is about the container. What are the difference between the containers and the yeah? What are the difference between the containers and the virtual machines? And also, how can we set up Docker, okay, to deploy our code into an EC2 instance, okay, which is something that I'm quite familiar with. I'm going to jump straight up forward all of that. So I know how to do that, and they also tell you how you can create a Docker file, how you can connect to the EC2 instance by them. Once you have pushed your code to the Docker image repository, you can pull from the EC2 instance that image, right, and run your application. And that's exactly what we did. And also, important topic is something that I dedicate quite a amount of time to understand how to handle errors in Node. You know, how to handle error in Node, particularly from Join or right now. So, as I know, Triton, as I know, as in, as they now being or they revamp as Triton. So I'm not going to dive deep into the error handling, just to know that, especially on Node.js error, it's important to distinguish between programmer's errors versus operational errors, uh, because it will help you to know how to handle and uh, how to handle errors and how to emit errors. Mhm. So how to handle error and how to emit errors, like this. So for example, here, even though they tell you is that, yeah, okay, then you decision between, exactly, just to figuring out how to deliver errors and, and how to handle them, right? So how to handle that, there are a few things that you can do that, and when it comes to deliver errors, uh, you can use or throwing them or using a callback or an event mirror. There are particular use case when you can do that. Okay, so I'm not going to dive deep into that. And in fact, uh, just going to make this quick recap of GraphQL. Okay, uh, no, in fact, and I won't go into GraphQL. You know, so I'm just going to leave this video uh, like that. So I wish you the best. Take care. Bye bye.